very fast because we forgot to record. We forgot to record. So hypothesis testing, a quick recap. Hypothesis testing, a quick recap of what we were doing in our last class by looking at this example, which I would want you to write down very fast. A manager of a departmental store is thinking about establishing a new billing system for the store's credit customers. For the store's credit customers. For the store's credit customers. Thank you very much. After that, after a thorough financial analysis, she determines that the new system will not be cost effective. Will not be cost effective. Will not be cost effective. Since the average monthly receipt will be less than 70,000. Since the average monthly receipt will be less than Kenya shillings 70,000. A random sample of 200 statements have an average receipt of Kenya shillings 66,000. Of Kenya shillings 66,000. Of Kenya shillings 66,000. Of Kenya shillings 66,000. Full stop. With a 5% significance level, comma, is there sufficient evidence to conclude that the new system will not be effective. Full stop. Assume a standard deviation of Kenya shillings 30,000. 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 So mention their solution. And before I dive in to do it, I would want to see whether there is any student who can just give a very nice shot at it. Let's see, I'm giving you 2 minutes, and please don't get tired with doing these things. You always learn best through doing. And don't also get worried over not getting it right. So remember, ladies and gentlemen, here we are dealing with a large sample that we have agreed, and we are saying the HO. O stands for 0, H0, H naught. So HO is a null hypothesis, where we are not foreseeing any difference between our population and the sample, which we'll be selecting here for purposes of studying, for purpose of analyzing. So there is null difference. And then, of course, we can see this lady saying, no, there is a big difference. She believes that this system is not effective, and it will not be effective if we shall be having an average receipt that is less than 70%, or 70,000, sorry, less than. Now, ladies and gentlemen, the test statistic here is the Z statistic, which will come and do our drawing like that. And we are saying, because it is a one-tail test, remember what we were doing in our last class, we had how many tails? 2 tails. And because of the 2 tails, we were taking the level of significance and then we were dividing it by 2. So here we only have 1 tail. And if it's 1 tail, the entire tail will take 0.0 what here? 0.05. The entire tail. Ladies and gentlemen, what I want you to do for me is a small favor. Please let it not get lost on us the fact that this half area, the total half area is 0.5. And if the total half area is 0.5, and we happen to be knowing this 0.05, could you kindly give me this area from here to here? Given that the 2 areas must add up to 0.5. So in this case here, these 2 areas must add up to 0.5. Therefore, this unshaded area will be 0.4 what here, somebody? 0.45. Thank you very much. This unshaded area will be 0.45. Now, ladies and gentlemen, remember our work in hypothesis testing regarding this Z score, regarding this Z statistic. Our work now will be to go to the table and then we read the area from here to here, the area from the mean. This 0.45, please look for it. Look for it. Let me get somebody to help me. Ladies and gentlemen, listen and listen to me very well. If you go to your tables, the 0.45 corresponds to 1.64 or 1.65, one and the same. So 1.64, and because it's on the left-hand side, it's going to be negative. So negative 1.64 like that. Now we come to the last thing here, which is the Z calculated, where we shall be comparing between now our sample and the mean, and the population mean. So what we have here is our Z calculated. Remember, our Z calculated will be equal to X bar minus mean divided by, here you can't talk of standard deviation. The one that doesn't have a bar there, where we are talking of X minus mu. X minus mu, this is where we normally divide by standard deviation. But the moment you say X bar, where you are subtracting the 2 means, then down here, you must use what we call the standard error. Down here, you must use what we call the standard error. The standard error. Now, this great lady has gone ahead and did some sampling. She sampled out 200 accounts, quite a big sample. And out of the 200 accounts she was able to sample, she got a mean receipt of 66,000. So the mean sample mean is 66, and the population mean is 70,000. But what about the standard error? What will I do to be able to get the standard error? What will I do to be able to get the standard error? I want to see whether there is any student who will be able to remember the formula of standard error. So standard error, ladies and gentlemen, equals what? Could you kindly give me the standard error formula? Kindly give me the formula of standard error. The formula of standard error, what do we have there? Standard error formula. I'm waiting. And today's, I can see from Lokai, it's like Lokai really takes her time to study these things. Thank you very much, Lokai. She takes her time to study these things. So she's telling me that standard error is standard deviation all over square root of n. Standard deviation all over square root of n. And this examiner has told us, ladies and gentlemen, the standard deviation to use. In this question, they have told us to use a standard deviation of 30,000 all over square root of n. We know that our sample size is 200. So divided by the square root of what? 200 there. So could you kindly give me this standard error? Ladies and gentlemen, kindly punch this. Thank you very much. Dahir has been able also to get that standard error. All of them, ladies and gentlemen, are able to give me a figure, a great figure of 21.32. What a beautiful figure. Now, having gotten this 21.32, come here right away, ladies and gentlemen, and give me the z-score. So my z-score, the sample, you told me the sample mean is 66,000, minus the mean of 70,000, all over this 21.32. So could you kindly give me this z value? Kindly give me this z value. My z value will be equal to what? My z value will be equal to what? Yep, according to Denzel, she's giving me a figure of negative 1.89. Is there any other student who can confirm? Yes, Lokai has gotten the same. Save for rounding off errors, we have this 1.89 negative. Let's adopt this. Let's adopt this. There is one thing that I forgot to tell you. Once you have these shadings, remember that the shaded area is an area of H1. This shaded area is an area of H1. And then the unshaded area, all these two areas are areas of who? Of H0. Unshaded area is H0, and then the shaded area is H1. Now, ladies and gentlemen, having marked yours like that, could you kindly advise me, this 1.89 negative, where does it fall on your diagram here? Is it falling in the shaded region or unshaded region? Somebody talk to me tonight or rather this evening. This 1.89 negative, where does it fall on this number line? On the number line. Lokai tells me shaded area. We have Denzel shed. Yes, negative 1.89 is slightly less than 1.6. It will be falling somewhere here. Yes, so you tell us that statement that the 1.89 negative falls in the shaded area, and therefore, we accept H1 because shaded area is for H1, and therefore we accept H1. We accept H1. And if we are accepting H1, what are we saying? That this lady who was saying that this system is not effective was right. The lady who was saying that the system is not effective, less than 70,000 receipt is what we will be getting, then the lady is correct. Although for us at section 4, we don't go into those details. Yours is to tell us, accept H1 or reject whatever. That is what you're supposed to be telling us. The most important thing is to know where your Z calculated, where is it falling? Is it falling in the H0 region or H1 region? That will be the most important thing for us. Now, ladies and gentlemen, if you allow me, I know some of you came in a little bit late. If you allow me, I'll still want to give you another exercise. I would want to give you just a small exercise. Mention there that a sample size, exercise 2, a sample size of 100, a sample size of 100 is drawn, this is exercise 2, a sample size of 100 is drawn from a normal population, whose mean is 30, and the variance is 2.25 and the variance is 2.25. Variance is 2.25. Is it reasonable? Is it reasonable? Is it reasonable to assume that the population, is it reasonable to assume that the population has a mean of 30, 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 given that the sample chosen, given that the sample chosen has a mean of 31, has a mean of 31, has a mean of 31. Into brackets, significance level is 1%. Into brackets, significance level is 1%. Significance level is 1%. So I want to give you exactly, 5 minutes. You try that, and then we'll be able to compare notes. If n is 100, we know our benchmark is 30. So it means that this is more than 30. So meaning that, again, we are dealing with a large sample. We are dealing with a large sample. And if that is the case, large sample, I know that calls for a Z statistic. Z statistic. So here, use Z statistic. Use the Z statistic and leave it at there, and then come and say H0, come and say H1. So here we happen to be having the population mean. The population mean, ladies and gentlemen, they have told us in the question. They have told us whenever you have population mean, everything becomes very easy. They have told us population has a mean of what here? A mean of 30. The mean here is 30. So automatically here, if you are careful, you must have noticed that this examiner is not directional. He's not telling you that the mean should be more than 30, should be less than 30. He's not directional. He's not giving any direction. He simply wants you to assess the reasonableness. So reasonableness, it could be unreasonable for being very small. It could be unreasonable for being very big. So in this case here, we use not equal to 30. So meaning that when you use not equal to, we are talking of how many tails? We are talking of 2 tails test. Tails ni ngapi? Ni mbili. Tails ni mbili. From there, ladies and gentlemen, we have our Z statistic. Our Z statistic. So our Z statistic here we'll have it being like that. So because it is 2 tails, not a problem. I'll come and shade my 2 tails. Of course, there is no tail at the middle. I've never seen any tail at the middle. So when there are 2 tails, I have to subdivide the level of significance into 2. So remember, because of the 2 tails, then each tail will take 1%, 0.01 divided by 2. So 0.01 divided by 2, which gave you guys what parameter? 0. You have to be careful. 0.01 divided by 2, according to Denzel, this gives me 0.005. Once you give me this, I'll be able to rush to my area from here to here. Because of the table that the examiner gives us, which is normally shaded from here to here. So how do I get this unshaded area on one side? I know for sure that the 2 areas must always add up to 0.5. Because if you remember a PDF, this basically is a probability density function. And the probability density function, ladies and gentlemen, has got 100% area. 100% area is 1. So 1 divided by 2, that gives me 0.5. So 0.5 half. And then we happen to be having this small shaded area 0.05. Therefore, this one will be 0.5 minus what is here. So 0.5, thank you very much. This gives me 0.495. Now, once I get this 0.495, I will run Very fast, get my Z table. Get my Z table, get inside the Z table, and then I use reverse gear. I use reverse gear to read an equivalent Z score. To read an equivalent Z score, reverse gear. Because here, whatever you have here is the entry. Is the entry. We are entering inside the table, and then we read reverse gear. So reading the reverse gear, ladies and gentlemen, what do we have here, ladies and gentlemen? The reverse gear. Using the reverse gear, what are we going to have? What are we going to have? Using the reverse gear, loci again tells me 1.64. Yes. So we have 1.64 because there are two tails. This other tail will be 1.64, although what here? Negative. Negative. Loci has said no. No problem, we are patient. Tell us what will be the corresponding Z score. Somebody help loci. Help loci. Somebody help loci. Somebody help loci. Anthony is saying 2.57. Nancy is saying 2.54. I'll need my own table. I'll need my own table. But there is no way I should go for these tables now that I have younger sons and daughters here. They need to help me. So 2.57 seems popular. Please, Nancy, just check it out. 0.495 is quite close to 2.57. So 2.57 carries the day. 2.57 carries the day. 2.57 carries the day here. 2.57 minus 2.57 carries the day. And please don't forget to say that this is a H1 shaded. Shaded is always H1. Shaded is always H1. The unshaded ones are the H0s. Please mark yours like that. Mark yours like that. Mark yours like that. Mark yours like that. After you mark yours like that, ladies and gentlemen, I would want us to go to the last thing, which is the Z calculated. So go to the last thing, which is Z what here? Calculated. So for Z calculated, the Z calculated, how will my Z look like? My Z, as usually, be X bar minus mu all over the standard error. Please write this in full. Standard error. Standard error. And then the very first thing that I will do, ladies and gentlemen, is to give my examiner the standard error formula. So the standard error formula, how does it look like? Somebody must have forgotten. Somebody. Dahir, are you able to remember the formula of getting the standard error, Dahir? Dahir, are you able to remember the formula of getting standard error? Nancy, thank you very much, Nancy. Nancy has told me that standard error equals standard deviation all over square root of what here? N. Thank you, and thank you very much. Denzel has also been able to remember that formula, yes. But you see, in this question, instead of the examiner giving me standard deviation, he has given me variance. The examiner has given me variance. So what should I do? Cry? You know, at times crying also helps sort out a few issues, but of course you can't cry because of an exam. They've even gone ahead to tell me the answers. You can see. Dahir has reminded me again the formula of standard error. Thank you very much, Dahir. But now, what is the relationship that exists between variance and standard deviation? How are they related? Lokai has even completed the entire thing. She's told me that standard deviation equals square root of variance. Thank you, and thank you very much. I can't put it any better. Standard deviation equals square root of the variance. And the variance has been defined for us. They have given us the variance. In this question, They have given us the variance, which happens to be what here, somebody? 2.25. 2.25. And therefore, the standard deviation here from some lady called Denzel, it should be coming to 1.5. I hope all of us are able to follow. Yes, standard deviation is the square root of the variance. Standard deviation is the square root of the variance. Oh, sorry for that. We shall overcome. Mimi mshamba, maybe this cage ninasikia na wewe peke yako. We shall overcome. Sorry for that. Okay. So standard deviation is 1.5. 1.5. Thank you very much. Now, ladies and gentlemen, having gotten that standard deviation, I know where I'm going to feed this. I want to get the standard error of my sampling. The standard error of my sampling, standard error, I know the formula. It is standard deviation divided by root of n. So it will be the 1.5 that you guys have given me divided by square root of 100. Divided by the square root of 100. Divided by the square root of 100. So 1.5 divided by 10. 1.5 divided by 10, thank you very much, Denise. Denise, 0.15, like that. 0.15, 0.15. That is the correct answer for standard error. Now, having gotten the standard error, I know it's one leading to something different. After I get the standard error, I know where I'm supposed to be using it. So my z-score at the end of the day will be equal to what? My z-score at the end of the day here should be equal to what? My z-score should be equal to x bar. X bar, they have told me the sample is 31. The mean population was 30, all over 0.15. So could you kindly give me this answer? So Lokai, Denise, Denzel, they're giving me 6.67. This is 6.67. So the next question, I told you this is one thing leading to another. Ladies and gentlemen, having gotten this Z calculated, we normally call it Z calc. Having gotten this Z calculated, what do you think will be the next thing to be done? Having gotten the Z calculated, what do you think will be the next thing to be done? The next thing that I will be able to do is to come and compare. Yes, we compare this 6.67. 6.67 falls here. Look at this thing keenly. 6.67 falls in H0, isn't it? 6.67 falls right there at the middle. Is that true? Where does this 6.67 lie? I'm waiting to hear. Of course, that's not true. So I'm waiting to hear from you great people. Denise tells me that this is supposed to fall in the shaded area. For sure, 6.67 is more than 2.57. It's more. So it falls around here. Remember, from the middle here, U is 0, number line. So 6.67 falls there. So tell us there that 6.67 falls in the shaded region, yes, right side. It falls on the shaded part. It falls on the shaded part. And as Lokai is even finishing it for us, right part. Although the most important thing is for you to tell us that this 6.67 falls in a shaded area, meaning that we shall accept which one? Meaning that we shall accept H1. Meaning that we shall accept H1. Thank you and thank you very much. We shall accept H1. Dahir is getting standard error of 0.12. Standard error of 0.12. Standard error of 0.12. Let's try all of us. This standard error according to Dahir should be 0.12. Remember Dahir, the formula for getting standard error is the standard deviation that you guys gave me 1.5 all over square root of n, and n, in this particular case, these guys decided to choose a sample of 100 units. So Dahir, 1.5 for 10 for sure cannot be 0.12, it will be 0.15. Just check again. It's supposed to be 0.15. It's supposed to be 0.15. It's supposed to be 0.15. Is that correct? Now, if that is the case, I would want us now to get onto the last stretch of this topic by looking at very good, don't put those square roots. Please don't do that. Square root is for only n. Square root of n down here. Thank you very much for coming outrightly like that. That is what we love, because the student who does that at the end of the day understands these things very well. Sorry for that. Sorry for that. So we have to start again. If you look at this particular question, ladies and gentlemen, the December 2017 question number 2B. A company produces two types of electric components whose information has been provided to you as follows. So we have mean life in hours, we have standard deviation, hours, we have sample size. Determine whether the quality of the two types of electric components differ significantly. Are they very different? So like I saw very many students doing, ladies and gentlemen, here, most of them were doing confidence intervaling, confidence intervals. Here we are not going to look for confidence intervals. This is a question that needs analysis and specifically hypothesis testing to see whether the two means are very different. So we shall come and start with our Z or T. Is this Z or T? This, if you look at the combined sample size, we are looking at standard deviation, 132, 149, ladies and gentlemen. Those are large samples, and as such, we shall make use of the Z statistic, of course. It goes without saying, these are large samples. So because it is Z, having known Z, we just leave it there to settle there. So now let us put down our fundamental hypotheses. The first hypothesis here, which is H0, the null hypothesis, is the one that will tell us that there is no difference between the two means. Here we don't have anything to do with the U. We don't have the population mean. So we want to ascertain that the two means are not statistically different. So H0 ile na kanusha inasema hakuna utofauti. So H0 will be X bar 1 equals X bar what here? 2. And then the second, or rather this alternative hypothesis, they haven't told us to study and tell them whether X bar 1 is greater than X bar 2. They just want us to study, analyze, and see whether the two variables are significantly different. So it means that the proper symbol that we need to use here is X bar 1 is not equal to X bar 2. Because they haven't told us to study whether X bar 1 is more or X bar 2 is more. They haven't told us that. If you read here, they want us to determine whether the quality of the two types of electric components differ significantly. They can differ when one of them is either big or, so in this case it should be less than or equal, or rather it should be not equal, not equal. You put the equal sign, you cancel it, not equal like that. Having done that, ladies and gentlemen, the next thing that I would need is to go straight away and give them the Z statistic. The Z statistic really here is a simple thing. So I'll need to come here. Remember, they have told me that the level of significance is 0.05. The level of significance is 5%. The level of significance is 5%. So this 5% has to be divided into 2 because of the two tails here, because of the two tails there, because of the two tails there. So what is 5% divided by 2? What is 0.05 divided by 2? Somebody help me there. 0.05 divided by 2, what do we have there? Somebody. 0.05 divided by 2, what do we have there? Somebody please help me. Please help me. Please help me. 0.05, the level of significance divided by 2, that will give me what figure? 0.025. 0.025, and of course this other area will be 0.025. So then I'm interested in this area from the middle to here. So I'll have to come and take 0.5 minus this. So 0.5 minus this, what figure shall we get? A good student is asking, where are we getting the 5%? If you see, I want to believe there is a bracket there. There is a bracket there. There is a bracket there in the requirement, which is talking about what here? Which is talking about 5%. Which is talking about 5%. If you see, I want to believe there is a bracket there. There is a bracket there. There is a bracket there in the requirement, which is talking about what here? Which is talking about 5%. Which is talking about 5%. Nancy is saying 95%. Ah, 95. Then I know it's a mistake from Kasnebe. Normally, it can't be such a high significance level. This 95% will be the confidence interval. Confidence interval. This is the confidence interval. So confidence interval plus significance level must add up to 1. So when the confidence interval is 95%, then the significance level will be 5%. You can never have this kind of a high significance level. Significance level. So significance level is supposed to be what here? 5%. It cannot be 90. You can't. You know, significance level is an error. Error. You can't do really an analysis where you expect to have an error rate of 95%. This must have been 95% confidence interval, the one that is in between. Sorry for that. So we have 5% which have been able to distribute, or the 95% at the middle. So ladies and gentlemen, come and give me this. This from here to here then will be 0.5 minus this, which will be 0. What here? Somebody has already given me a figure of 0.475. So using reverse gear, let's use reverse gear. Let's use reverse gear. Using reverse gear, get to your normal tables, read 0.475 in the entry, inside there, 0.475, and then you use reverse gear to give me the Z score. Somebody 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 give me the Z score. So Z score, what do we have here? Today I've used this 1.96 severally. Lokai is giving me a figure of 1.96, which Denzel is able, Mr. Denzel is able to confirm. So 1.96 negative there. So remember, the things here must always be done what you shaded all of them. Must be shaded all of them. So ladies and gentlemen, after getting the Z statistic nicely, don't forget that this will be denoted as H1. The other one will also be denoted as H1. These two will be H0s like that. So now we go to the last stage, which is the stage of Z calculated. So Z calculated. So remember that now here, ladies and gentlemen, we have got how many? We have got two samples. You can't talk of X bar minus mu. No. Two samples. So what we have here, it will be difference between the two samples like that. X bar 1 minus X bar 2. All over the standard error. All over the standard error. Remember, standard error, whenever you've got two samples, the standard error will look like this. Square root of. Whenever you've got two samples, this is how our standard error will look like. Standard error will be the standard deviation of 1 squared all over n1 plus standard deviation of 2 squared all over n2. So could you kindly help us here? Kindly help us here. So a very important formula of getting standard error, whenever you've got how many samples? Two samples. Whenever you've got two samples, you must always reason like this. So the examiners, remember S stands for standard deviation. S stands for standard deviation. So for X is 132. So I'll talk over 132 squared all over N1. All over N1. N1, sample size 1 is 120. Is 120. Plus, ladies and gentlemen, sample 2, standard deviation is 149. So 149 squared all over N2. N2, which happens to be 110, which I'm able to see some students giving me an answer. I'm able to see Denzel and Lokai agreeing on some particular answer. They're giving me 18.63. But I would want to get someone else, apart from the two. Someone else should be able to confirm that answer for us. Wycliffe is giving me the same, 18.63. 18.63, thank you, and thank you very much. So I'm being told that the standard error is 18.63. Now come back to our Z calculated equation, and then we plug in. And I hope all of us have been able to get that 18.63. 18.63. So ladies and gentlemen, we have our Z calculated as what here? X bar 1. X bar 1, the first mean they gave us there for X is 1600. So on top of 1600 minus X bar 2. X bar 2, what do we have there? 1528. So minus 1528 all over the standard error. The standard error, ladies and gentlemen, which happens to be the figure that you gave me, 18.68. HP, you have to check your answer. 18.1 is quite off. I know it's near, but 18.1 is quite off. It's quite off. It's quite off. So I want someone to give me the final answer of Z calculated. Lokai, Denzel, Denise, they're giving me 3.86. So having gotten 3.86, what do you think would be the next thing to be done? 3.86 What do you think could be the next thing to be done? The next thing, ladies and gentlemen, to be done, having gotten the Z calculated, is to come and fit this thing here. And I can see for sure that the 3.86 is falling on the shaded area. 3.86 is falling on the shaded area. So 3.86 is falling on, so you simply say there, falls on the shaded area, therefore accept H1. Accept H1, yes. And when we accept H1, what conclusion are we having? We are saying that the two samples we selected from our population do not have the same means. Look at H1, what H1 says. They don't have the same means. Meaning that their means are statistically different. Their means are what is statistically different. But for our case, if you tell me that this 3.86 falls on the shaded area, and then you go ahead telling me accept H1 because shaded area is the area of H1, I'll be able to accept everything. I'll be able to accept everything, and that is it. I'll be able to accept everything, and that is it. Is that okay? Is there any student who has a question? Is there any student who has a question? Any student who has a question? Is there any student who has a question? Any question? So you mentioned they are small, so it means they differ significantly, yes. They differ significantly. That difference is so material. It's so material. It's so material. Yeah. Prayers time, yeah, I can give you 5 minutes. As I give you 5 minutes to go and pray, I'll be talking about something that happened to some student of mine who happened to come for some interview for a big corporate where I'm involved in terms of hiring their key staff. And this basically was a serious position, CFO, Chief Finance Officer. This gentleman was a great gentleman. He scored very well in many other systems. For example, systems, SAP, Excel, because I have to ask an Excel question when I'm around there. Excel, the guy, was very thorough in all those areas. But now this guy, there is something that he could not crack through. You know, when you are a CFO, Chief Finance Officer, has to be very good in dealing with all stakeholders in the organization. You have to be good in terms of legal matters. That's why we teach you company law. There are those things you're supposed to know. To even advise directors who are coming as new, come and tell them that if you guys go to the board and you're not able to agree, all of you, number one, it is the majority who will carry the day, whose resolution will be based on the majority. And then even after that, don't become enemies at the board. We are just here to push this wheel of this company forward. And of course, majority can't be wrong. That's what we call force versus habit. If it reaches a point, for example, where they can't see eye to eye, these directors can't see eye to eye, advise them as the CFO. Tell them the case of Sharp versus Dowitz, where two directors could not see eye to eye, and yet the operations of the company had to continue. Ladies and gentlemen, they had to continue. Why? Because, you know, a company, once it is there, it is different from the personalities. So even if it has reached a level where you can't see eye to eye, it is important for you to come and do your obligations. You carry out your obligations in the company. For example, sign check. Don't refuse to sign check to you because you're not able to talk to so and so. No. Remember, it is the company which is calling upon you to go and sign that check. So that gentleman did very, very well. But what now surprised me most, this gentleman scored 0 in auditing. He scored 0 in auditing. In auditing, he scored 0. And you know, auditing is a simple subject that you guys are supposed to internalize. Actually, it is the simplest subject that I've ever seen. Simplest paper, which is very applicable outside. There is nobody who will ever employ you as his accountant if you don't know how you will be dealing with auditors. Look at even the government. If there is anybody who is working at the county, any county government, it'll tell you how problematic it is to deal with auditors. You need to have that acumen. You need to be skilled enough to be able to handle auditors very well. So this person could basically answer questions on auditing scantily, and he lost the job despite having been very good in terms of technical skills. Now, before they come back at about 6:40, I would want, ladies and gentlemen, to hear how good you are in terms of auditing. If, for example, today you got a job to audit RCM College, where are you going to start this exercise from? Remember, we have already signed the engagement, so don't tell me I'm signing over again. If you have accepted the job, you've gotten the job, so already now you are with us. So where will you start this auditing from? This is quite practical, and I'm so sure this one you'll have to meet it in your interview sometime in the future. Not very far away, very soon. So somebody has gotten a job here with RCM. Thank you very much. Denzel says background knowledge. I like that. Any other student? Denzel is telling us the very first thing that he has to do is to understand RCM. Is it a registered company? Who are the directors? What kind of business does it engage in? Yes, basically to carry out like what we call a pastel, political, or all those. You look at all those strengths, weaknesses. Get, for example, the previous auditors. If, for example, you are a new auditor, the previous auditor's file. Try going through what kind of recommendations was he giving. Try to understand the internal controls. I'm saying that as I wait for the students to come back. Once they come back, they should be able to tell us. Ladies and gentlemen, the key thing, like Denzel is telling us, ladies and gentlemen, is to appreciate like this company. How does it operate? For me to be able to know the proper auditing methodology that I'm going to use to audit this organization, and for me to be able to understand the operations of the company very well, I have to look at what we call internal control systems. Who can define for us what is an internal control system? What's an internal control system? Now we are doing QA, you are introducing this. This is a life skill, Ladies and gentlemen, ICS, internal control system, is that particular system that we put in place to ensure that all revenues of the company are collected. Expenses that are incurred at the end of the day are expenses that were genuinely incurred by the company. Right? Ladies and gentlemen, these controls, we are putting them in place to ensure that the objective of the entity will be met at the end of the day, which is maximizing of what here the company's profits. So if it's a school, for example, at the gate, we must put soldiers. So these soldiers, their role is to ensure that every student pays the school's what here as a control, is a control. So remember, for you to say really that this company has got strong internal controls, they have to meet the 5 objectives. Who is able to remember the 5 objectives of ICS? The 5 objectives of internal control systems for us to say for sure this company has a strong internal control systems. That here, the moment you come back like this, please notify us. We continue with QA. So the internal control systems objectives, normally we talk of a stop like that. We are saying that we can only have our systems being said that they are strong if you're able to get accurate financial statements, if our assets are safeguarded, if we are getting reports on time when we want them, if there is order in the organization. Ladies and gentlemen, if the controls will be able to help us, to prevent fraud and what here? Fraud and error. Fraud and error. Now, ladies and gentlemen, if the internal controls are meeting these 5 objectives, then as an auditor, I will do very little work because the internal controls are strong. So if they are strong, number one, I will not really do a lot of work. Auditing. No. If the internal control systems are very strong, what I will do, for instance, I'll be working with what we call small samples. I'll be picking less than 30 vouchers. I don't have to do like the continuous audit. If the internal controls are working, I can even decide to come and do the end of year audit, the final audit. Oh, but I remember again, even if the internal control systems are working very well, if this company pays interim dividends, I have to go in between the year to check. But the most important is that if internal control systems are working, I'll be doing very little work. But ladies and gentlemen, what if the internal control systems are not working? If the internal control systems are not working, then I have to do a lot of work, what we call substantive tests. Substantive test, this of course comes from the word substantial. The moment I realize that your internal control systems are not working at all, I'll have to engage in what we call the substantive test, which we normally call R, A, E, or U, like that. R standing for what here, somebody? The analytical. Once you are in an interview and then you raise this kind of points here, analytical procedures, these guys will take you straight away. We have an inquiries. We have what in this case here we call like this is observation, this is inspection, observation. We are waiting for Dahir. Dahir, once you come on board, please notify us. Notify us, we continue with QA. Here I'm only making noise because I don't have any place to go. So we have this U. This U stands for recalculation, and what year? And the performance. Recalculation and what year? Performance. Listen to me very well. Once I realize that your internal control systems are weak, what I will do is to do a lot of work. I'll ask you to give me like your 5 years financial statements, and then I'll analyze, I'll calculate ratios. That's what we call analytical procedures. We have an inquiry. Because your internal control systems are not working, I can see his back. Because the internal control systems are not working, I have to inquire from third parties. I have to do what we call data circularization. I have to circularize something to your bank, etc. So etc. So as I switch gear to quantitative analysis, this gentleman of mine never even knew any assertion. Is there anybody who has ever heard of management assertions? Management assertions are the hypotheses, the claims that the management are putting in place, the claims that they would want the public to believe. So the management assertions, ladies and gentlemen, they are normally 9. We normally talk of ACCA cover. They're normally 9. So what these managers want us to believe, of which you as the auditor has to accept these with some pinch of salt, because mostly these allegations, assertions are not truthful. So the first one, for example, is what we call accuracy. They are telling us that our financial statements are accurate. What a lie. I have to wear what we call professional skepticism goggles. Look at these things critically. Ladies and gentlemen, they are telling us that our financial statements are complete. What a lie. We know outside here, people normally make 2 sets of financial statements. There are financial statements that are taken to the banks, which in this case, you have to be embellished to look that the company is doing very well, to show huge profits, to show huge revenues, to show little expenses. So they are window dressing, to take them to a bank so the bank can give a loan. But the same company get their financial statements, ladies and gentlemen, which they have taken to KRA, trust you me, their revenues are never complete. Their revenues have to be small like that. Ladies and gentlemen, this is cut-off, allocation, classification, like they're telling us that all the transactions that took place, we were able to journalize them very well. If we bought a motor vehicle, we debited the motor vehicle account, credited our bank account, we paid for that vehicle immediately. But we know, you and I, at times these companies here would want to boost their purchases. They'll take a wrong asset and put it in the purchase. So they buy a motor vehicle, but they take that expense. They take it to purchases account, debit purchases account. So as an auditor, I have to be aware of this. We have occurrence, valuation. existence, rights and what here? Obligations. So we should hold one of the fine days. I can do one session for you free of charge for you to appreciate what I'm talking about in the context of what, teaching you for your syllabus, but teaching you for the industry, Otherwise, allow Mwalimu here to teach you the concept of small sampling, into bracket what we call the T statistic, into bracket what we call the T statistic, into bracket what we call the T statistic. And for me to do small sampling, ladies and gentlemen, I need more time. 10 minutes cannot be enough. So I want to take this opportunity to thank you. It has been a pleasure hosting you. In our next class, I should be able to finish these small samples. And of course, now from there, we'll be able to discuss the other areas that you would want me to do, like a student raised here, the concept of network analysis. So I want to believe that you have gained something today, including audit. There are students who keep thinking that Mwalimu only knows QA. No. There is no paper of CPA I can't teach. I've got the students who tell me, Mwalimu, how can you summarize this audit for us in a week? And I've done that. The students have done what year past. So thank you very much. And unless there is a question, I would want us to end it there. Any question, feedback? Feedback is also very important. Very important, okay. Yeah, welcome, Denzel. Feedback is very important. Yeah, Charity, thank you very much. I would want to see you talking next time. Charity, you were talking a lot when we started financial management. And nowadays, I don't see you in my financial management classes. Please get back there. Ekabaila, welcome. Lokai, welcome. We shall be doing these great things like that. So what do you think of this session of auditing? The session of auditing? Or you deleted so fast? Why? It was getting interesting. We can organize. I wanted us to start on this, but I realized that we only have 10 minutes. So this practical auditing class, when can we organize to have one class? The practical, so that I can come with working papers, show you how it happens. And of course, it has to be a free of charge. You make auditing so simple. Thank you very much, Lokai. Yes, especially when we will go to this particular, like the audit test, like when you are told here to audit the sales, how would we master the sales cycle, etc. So now we need to get tomorrow I normally operate from Kajiado. I don't have very good internet there. Tuesday onwards, you make everything simpler, we shall overcome. Asante sana. Only that I have my time is squeezed, but fortunately for this, from last week, I don't think I'll be getting some other new assignment in the near future. So I want to dedicate myself fully to you, and I'll be teaching most of these papers. Tuesday, fine. So Tuesday, what time? Can we talk of Tuesday at 5:30? Tuesday at 5:30 for the practical auditing, class. 5:30. They're here. Tuesday. You guys have an Excel class at 8, and that's what I'm talking of. Tuesday at 5:30 or 6, or even 6:30. Tuesday 5:30. Tuesday 5:30. So for the practical auditing class, I would want us to form a WhatsApp group for the practical auditing class, because of course, again, it can't be a one-off, but this one I'll teach you for free throughout this practical auditing, because I want to also leave a legacy behind, a legacy of students that I taught who are holding very senior portfolios outside their courtesy of what we told them. So we want us to have a WhatsApp group for the practical class. So this is my number for the students who would want to join. Please just reach out to me on WhatsApp, and then we get started right away. Otherwise, thank you very much. 5:30 is too early, maybe 6:30. To accommodate everyone, I always like accommodating everyone. Let's do it at 6:30. To accommodate everyone, because we have 6:30, 7:30. 7:30 to 8, 1.5 hours is good to accommodate everyone. Let's have it at 6:30. When is the FM class? FM class is on, was it yesterday? Saturdays. FM class is on Saturdays. Great, thank you very much. So see you on Tuesday at 6:30. The other thing, ladies and gentlemen, as you come to this particular class, if you have agreed 6:30, all of us must keep time because I'll have presented so many working papers. If you come late, like 30 minutes, you'll not be able to understand anything. So thank you very much. Please keep